Okay, so what kind of want to go over the homework? If you can look at my screen, I do have the optional homework up. Like I said, you know, inheritance is just like the first time you learn chapter four, which is creating objects. It's like once you've done it enough times, it just makes sense, right? We're just kind of just separating out like information of an object that is common to other classes so that we can have a parent class and a child class, okay? Now, this is optional work because I realize that there's only about a month and a half left of school, right? But if you do 9.6, 9.7, 9.8, I think it'd be very good advantage to you. So that it's actually a lot of repetitive work in chapters 9 or programming problems 9.6, 9.7, 9.8. The one that is not, the one that's not optional is the sorted int list. I just kind of want to talk about this. You can read the directions. I know it's kind of big. It's actually an assignment that I've got from the data structures teacher. Now, this is one of the assignments that he gave out. I talked to him about it. He likes to have students to come into his class that know how to sort, okay, that know data structures already. So the way this works is that there are two files that you can use or that are already done for you that have the int list, but what you're going to have to do is make a sorted int list. So I'm going to go ahead and just pull this example up really quick. So from IntelliJ, if you're going to import the work for this, you just come over here, go to new project, and hit next. Now I'm going to put this off of my desktop. Let's see. So users and Madrigal desktop. Okay, hit OK. And we'll just call this one int list project. Int list project. Okay, so put that right there as well. Hit finish. Okay, so you need to import those files. If you come over to source, just simply grab those files from Dropbox. I already have the files on my desktop, so I'm just kind of pull that window into view. So what I'm going to do is just highlight them both and then drag them and put them into source. And that did not work. What the heck? That window was awesome with this stuff. Oh, maybe because I didn't highlight where I wanted to put them. All right, there you go. Get OK. And now those two files are here. Okay, you have the int list, which is the class that does the maintaining of the int list. And then you have a int list test. So I'm going to go ahead and run the int list test. Okay, it compiles and runs for you. Okay, now I just want to kind of explain this on the whiteboard to kind of give you an idea how this is actually done. So the way this works, if you actually look at the IntList class, is the IntList class simply manages an array. Okay, now it's a little weird. This is the way things are done in data structures. Is you have an array of integers, but then you have the number of elements, which is initialized to 0. So as you add things to the array, you're going to increment that value. But you have to make sure that your size of your array is big enough to hold this value. Okay, so if you look at your constructor, you pass in the size, right, the number of items you're going to add, right, and then you just add those values, right? So you have like an initial size. If you go over here, the size was initialized to 10. Okay, so this is a little weird. Okay, so but it helps you prepare for data structures. So if you hop over here, okay, this is the way this works: is you have this class that has this array that is going to be of size whatever it is that you set it to. All right, so here's your array. Now you have this variable called the num of elements. Let's call it num of e, and it's set to 0, meaning there's nothing inside of your array. Okay, now when you go to add a value to your array, what's going to happen is you're going to take in an integer value. You're going to check to see if number of elements is equal to the list length, the array length, and you're going to say I can't add any more values. Okay, if you're not, then what you're going to do is you're going to add those values and then increment that number. So you hit add. So this is the way this works. So here's the add method. And if you initialize this to be 1, 2, 3, 4, 5, oops, 4, 5, 6, so size 7. The first time you add a number, we'll just say 7. Number of elements is 0. Okay, number of elements is 0, right? So this 7 is going to be put into this spot right here. Okay? Then number of elements is going to be incremented. That's what the increment was done for. Plus, plus. Okay, so now it's 1. Okay? Then you keep adding items, you keep adding numbers. We'll just say like you just keep coming down here. Like say you have like 10, 100, 13, 17, 18, 9, 32, right? So you keep adding items, right? They're going in here. So you put your 10 here. Next you come in, right? So then this gets incremented. So this goes to being 1 to being 2, right? This number of elements. Number of elements, right? Now you have 2 items. Then you added your 13. Now you have 3 items. Then you added your 17. You have 4 items inside of here. You added your 18. You have 5. You added your 9. You have, oops, messed it up. You added your 9. You have 6 items inside of here. And then the last thing you added was, I don't know what that was supposed to be, a 32. A 32. And then you had 7 items inside of here. Okay, so now number of elements and the length of this array are now the same size. So the next time we call add, or let's just say we add, I don't know, 0 for some reason, okay? That method add, if you look at the way it's set up, it's going to check the number of elements that it's keeping track of. Once it equals to the length, then it just says the list is full, I can't add anything else, okay? So what's going to happen is add is going to check this number of elements over here. Probably should use a different color for that. Number of elements, and now it's 7. The length of this is also 7. So it's just going to say it's full, it can't add any more values. So let's hop back over to the program and see what happens when we add more than 10 items. Okay, so I'm going to go ahead and copy this all once again. So that's 8 items added in, and another 8, or another 4. So that's 12 items added. So after the 12 item, it's just going to keep saying it's full, right? So when I run this, it said it couldn't add in these last 2 values that I tried putting in because it was full. Now let's just I want to make this a little more easy to read. Okay, we'll just do we're just adding numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11 and 12. Okay, so now when I run this, okay, still can't add the last 2, but you can see 1 through 10 was able to make it inside of the list before it cut us off. So what you're going to do as part of inheritance is you're going to use the same class, inherit from the same class, except you're going to make the insertion sorted. Okay, so you're still going to prevent things from getting entered once it's past the length, but you're going to have to find a way to sort these. Okay, now the sort is in insertion, meaning the very first time you add something, if there's no elements, it goes in the front of the list. Okay, so this is actually pretty simple. I know it might seem difficult when you first read it, but let's just think about the add method for a bit. Okay, so the way the add method worked in the IntList was it just checked to see if the list was full before it attempted to add. Okay, but this time you're going to check to see if the list is full, and then you're going to add, except you're going to check the numbers to see if it's actually greater or less than. Okay, so you have to use a for loop for this. So the idea behind this is you have an add, and let's just say we're going to add 13. Okay, now here is your list. We'll say we initially made this of size 0, 1, 2, 3, 4, 5. So the size of this is 6. Okay, the number of elements, we'll say like num e starts off at 0. Okay, so the first time that you add something, okay, you add the 13, right? You're going to come in here and you can say, okay, number of elements is 0. So I'm going to go ahead and put 13 right here. Okay, now the next time you add something, we'll just say we're going to add 7, which is smaller than 13. Okay. Now what we're going to do is we're going to try to insert this. Okay. You're going to see that number of elements after it added the 13, like this should have been incremented, right? There's a plus plus there, so now it's 1. So now you can say, okay, there's 1. Okay, so I have 7. You're going to have to take this 7 that's coming in, and you're going to have to compare it to this 13. You're going to say, okay, well, is 7 greater than or less than 13? Oh, it's less than, so I need 7 to come here, and 13 needs to be moved to spot 1. Now, this is where you have to be really careful because you might actually overwrite your data. So what you're going to do is if there's room for this 7 to be inserted, you're going to have to move 13 to the next spot first, and then you can insert 7. So now your new array looks like this, right? You have the 7 here and the 13 right there. Okay. Now let's think about what happens if we come over here, we add a 3. Okay. Now what's going to happen is the very first time you're going to check, you're going to say, okay, well, dang, okay, I want to add a 3 in here, but 3 is less than 7. I need to move 7 and the 13 over. So this is where it gets a little complicated, okay? This is where you need to think, okay, how can I move the 13 over first and then the 7 over next, and then I can insert the 3. Okay, that's the kind of stuff that you need to think about. You can use for loops. My suggestion, just to kind of give you a hint, is probably be take whatever the number of elements is, right? Because you know, like everything inside this list is already sorted. So you only need to compare yourself to the first element, right? So like if you want to compare yourself to the first element, if you need to be inserted right there, you take anything from that location to the end and move it over one time. Now, as long as you're checking before you're doing your insertion, if there's room for this element, you shouldn't have to worry about the list being full because you already did that check first, right? Because as soon as the list is full, you're not comparing anything. You're just saying, I'm full. So what's going to happen is you should probably just take your number of elements and start from the top index and decrement down, meaning you know if 3 belongs here, then you know that this location needs to move over 1, and then that the 7 needs to move over 1. Okay, so this is what your array looks like right now. You have a 3, you have a 7, you have a 13. Okay, now let's just come over here and say, okay, let's go ahead and add a 5. You can take the 5, you can compare it to 3, say, oh, nope, 3 is less than 5. Let's compare it to the next one. Oh, nope, 5 needs to be inserted wherever the 7 is at. So now you need to move 13 and 7 over and insert the 5 there. Okay, so that's what I want you to think about. It really isn't that complicated. It's just the use of for loops and doing some if statements and comparisons. Remember, it is primitive data, so you can use the greater than, less than, equal to signs. Okay, so just kind of think about that. It's not really, I mean, if you get like super stressed out about it, we can talk about it in one of my office hours. But I want you to kind of think about it first. Like, just take some time to think before you actually start Googling how to do this. Okay, like just take some time and play with it because these are the types of questions you're going to have to answer whenever you get to your data structures class.